everyone. Good morning. It's so good to be with you this morning. Well, I just found a postcard for Miss Post, so let's see what it says. Miss Post, I need some help understanding how to compare fractions, especially when there are different numbers. Will you please explain this to me? Great question. I think one of the easiest ways to compare fractions is by using area models. They help you picture what the fractions represent by letting you compare the shaded areas in the two circles. Now we use these symbols to compare fractions. This is greater than, equal to, and less than. If you ever get greater than and less than mixed up, remember to read from the left to the right, just like you would in a book. So if the left side of the symbol is the big open part, then you know that's greater than. And if the left side of the symbol is the smaller closed part, that's less than. We're going to talk about three types of fractions today. Fractions with the same number in the denominators, fractions with the same number in the numerators, and fractions that have completely different numbers in the numerator and the denominator. Now let's compare area models for fractions that have the same denominator. We're going to use 3/7 and 5/7. I have two circles that are both divided into 7 parts. And the denominator represents those numbers of parts. Now, if we're picturing a big circular cookie cake, then this is how many total slices there are. Then the numerator is how many of those parts we shade in. So if we're talking about pizza or cookie cake, you can think of it as how many slices were eaten. Now, on the first area model, we said that 3 parts of the whole, or 3 slices, were eaten. So let's shade that in. On the second area model, we said that 5 parts of the whole, or 5 slices of the pizza, were eaten. So let's shade that in. Okay, so we have 3 out of 7, and we have 5 out of 7. Now let's compare. The model shows us that 5 out of 7 is definitely greater than 3 out of 7. So here's the trick. When your denominators are the same, look at the numerator. The larger numerator belongs to the greater fraction. In this example, since 5 is greater than 3, then we know that 5/7 is greater than 3/7. Now let's look at area models to compare fractions with the same numerator but different denominators. We're comparing 4/5 and 4/9. The first circle is divided into fifths, and the second circle is divided into ninths. And in both circles, we're going to shade 4 parts of the whole circle. So let's compare. This will be 4 out of 5. That's a lot. And this will be 4 out of 9. Not nearly as much, is it? So here's the trick. When your numerators are the same, look at the denominators. The smaller denominator belongs to the greater fraction. And if that seems a little wonky, think of it this way. If a pizza was only cut into 3 or 4 slices, those would be some really big slices. If a pizza is getting cut into 20 slices, those would be some really, really small slices. So the smaller the denominator, the bigger the pieces. Okay, now let's compare fractions that have different numerators and different denominators. Which fraction do you think is greater, 3/5 or 4/7? I'm going to show you a fun way to solve this problem called the butterfly trick. First, write down both fractions. We have 3/5 and 4/7. Next, draw your butterfly wings like this so that the two ovals crisscross. Then cross multiply and write down the answers at the top of the butterfly's wings. 7 times 3 is 21. 5 times 4 is 20. And 21 is greater than 20, which tells us 3/5 is greater than 4/7. Thank you for the postcard. I hope today's lesson helped you in comparing fractions, and I hope you have a great rest of the day. Remember, keep a positive mindset, grow every day by reading and asking big questions. There's nothing you can't do if you put your mind to it. I'll see you soon.